Welcome to this Strategy Masterclass Explainer, where we're going to anticipate the examiner's next move and completely conquer the OR gate for Cambridge Syllabus 9618. Okay, let's just dive straight into this. I want you to think of your Cambridge Computer Science exam not just as a test of what facts you've memorized, but as a high-stakes strategic game of chess. To win, you literally need to think 5 moves ahead of the person marking your paper. Let me set the scene for you by describing 2 types of students I see all the time. We'll call them Alex and Sam. Now, Alex is essentially a walking encyclopedia. He studies for hours, he overloads his answers with raw computer science facts, and honestly, he could probably draw every single logic gate blindfolded. But here's the catch: he offers absolutely zero critical analysis. He has memorized the entire chessboard, but he doesn't actually know how to play the game. His exam paper is just a wall of textbook definitions. Then, on the other hand, there's Sam. Sam gets into the exam hall, the clock starts ticking, and he just rushes. Sam sees the word gate in a question, completely panics, ignores the specific command words entirely, and totally misses the core requirements of what the examiner is actually asking for. Today, we are going to look closely at those flawed approaches. We're going to take those red pen marks you get when you rush like Sam or over-explain like Alex, and we're going to correct them. We're going to turn you into the absolute chess grandmaster of your Cambridge exam.
Believe it or not, examiner reports consistently highlight this seemingly fundamental topic as a major stumbling block for students globally. But we're going to fix that today by thinking 5 moves ahead. Now consider this quote directly from the principal examiner reports. The OR gate is one of the most misunderstood areas. It sounds crazy, right? The OR gate, its symbol, its function, its truth table, it sounds so incredibly basic. It's just a simple logic gate where if either input is true, the output is true. So why on earth does it consistently trip up thousands of well-prepared candidates every single year? Well, it's because the examiners aren't just testing if you know what an OR gate is in isolation. They don't just want a simple regurgitation of a truth table. They are testing if you know how that specific gate interacts within a much wider, far more complex digital system. They are hunting for your methodology, your analytical skills, and your absolute precision. In this explainer, we are going to deconstruct exactly how you can stop throwing away these incredibly easy marks and start building answers that examiners love. Here is our strategic blueprint for today's explainer. We'll start with the core principles, move into the procedural framework, tackle the top examiner warnings, and finish by mastering critical analysis. Let's kick things off with Section 1, Core Principles and Connections.
Top-performing students don't just memorize the OR gate's truth table. They show a deeply connected, conceptual understanding that easily transfers to completely unfamiliar contexts. And this brilliantly illustrates a vital hidden secret to dominating Cambridge exams. Listen closely, because whether you are taking syllabus 0417, 0478, 0983, 0984, 2210, or our primary focus today, the A-Level 9618, the golden rule remains exactly the same. Cross-topic connections equal top-tier marks. When you talk about an OR gate, you have to ask yourself, can you seamlessly connect it to Boolean algebra? Can you link it to how hardware components physically process binary data on a motherboard? Can you relate it to conditional statement logic in your programming code? This is exactly where Alex, our first student, completely fails. He just writes 1 + 0 = 1 and puts his pen down. The true grandmaster connects that single logic gate to the overarching system architecture. Before we continue, subscribe to our YouTube channel, AC Exams, at acexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
So your foundation really rests on precise definitions and integrating this logic gate with other areas using systematic analysis and solid evidence-based reasoning. The absolute crucial point here is that you must adopt a structured framework for your answers. Have you ever heard of the PEEL framework? That's point, evidence, explanation, and link. Let me tell you, this is your ultimate secret weapon. When a Cambridge examiner asks you to explain the function of an OR gate within a specific complex circuit, you do not just dump random facts onto the page. You systematically make your point, then you provide hard evidence pulled directly from the diagram or truth table they've given you. Next, you thoroughly explain the causal relationship, how the specific inputs physically dictate the outputs. And finally, you link it all back to the system's overall purpose or the original question. That is how you guarantee maximum marks.
Moving on to Section 2, the procedural framework.
If you want to capture those critical method marks, you need to follow this strict 5-step sequence every single time. Step 1, identify key elements. You absolutely must decode the command word first. Is the examiner asking you to describe, evaluate, or state? Because those 3 words require 3 completely different types of answers. Step 2, apply the relevant principles. Step 3,
Execute your analysis with crystal clear working. Let me emphasize this. This is your ultimate method mark strategy. Even if your final binary output is completely wrong because you made a silly addition error under exam pressure, showing your step-by-step logic gate resolution will literally save your grade. Step 4, verify your results. Step 5, present everything in the appropriate format requested. Imagine for a second watching Sam, our rush student, rewrite his chaotic answer using this exact framework. In your mind's eye, you can see the examiner's red pen marks literally transforming into green check marks. He stops rushing, he breaks down the logic circuit systematically, and his mark potential skyrockets from a failing grade straight to 100%. When you are tackling these examination questions, you must systematically extract data from binary representations, calculate accurately, and conclude with undeniable hard evidence. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get back into it. You have to be able to look at a sea of ones and zeros and instantly understand the story they are telling. It's not just about doing the math. It's about interpreting what that math actually means for the computer system in front of you. Let's shift gears to Section 3, Top Examiner Warnings. Every year, principal examiner reports identify 3 specific recurring mistakes that consistently and tragically cost candidates massive amounts of marks. We are going to dive into an interactive workshop right now to tackle these. Let's start with Challenge 1, Data Scan. I want you to picture a highly complex data table on your screen, showing a massive sequence of binary inputs feeding into a tangled network of OR gates. If I threw a 60-second visual countdown timer up right now, could you extract the core trend before the buzzer goes off? You need to trace the ones and zeros rapidly and accurately under pressure. If input A is 0, B is 1, and C is 0, and A and B go through an OR gate, boom, the output is 1. You must be able to perform these calculations on absolute autopilot so that your brain is completely free to do the heavy lifting of writing out those complex, evidence-based conclusions we talked about. So make absolutely sure you never confuse cause and effect. Always verify your edge cases and tailor your answer incredibly tightly to the provided context. Let's jump into Challenge 2 of our workshop, Find the Flaw. I'm going to read a sample paragraph from a real, flawed exam paper, and I want you to find the sentence losing the marks. Here it is. The OR gate outputs a 1, which causes the sensor to trigger, meaning the inputs were definitely both 1. Did you catch it? Let's break down the examiner commentary. That sentence falls right into mistake number 1, confusing cause and effect. The student claimed the output being 1 means the inputs were definitely both 1. But wait a minute, that's an OR gate. For an OR gate, it could be a 1 and a 0 and a 1, or a 1 and a 1. They completely confuse the logical cause. Mistake 2 is forgetting boundary conditions. What happens when the entire system resets? What happens at the absolute physical limits of the binary register? You have to account for that. And mistake 3, lacking specific context. If the exam question is explicitly about an OR gate in a factory temperature sensor system, you cannot just lazily talk about input A and input B. You have to explicitly write temperature sensor A and pressure sensor B. Context is king.
And here is a massive critical examiner alert. You must consistently define your terms before applying them in your extended responses to completely prevent terminology confusion. Clarity is your best friend here. Before you launch into a massive multi-paragraph essay about a complex logic circuit, take a breath and state clearly what an OR gate does in one simple sentence. Let's do Challenge 3 right now, speed writing. Imagine you have a 30-second timer to write one absolutely perfect Peel paragraph. Ready? Go. Point. The OR gate acts as a fail-safe in the factory. Evidence. As shown in the provided truth table, if either the primary or backup sensor inputs a 1, the output is 1. Explanation. This logic guarantees that the alarm triggers safely even if one individual sensor completely fails. Link. Therefore, this specific logic gate perfectly satisfies the critical safety requirements of the given factory scenario. And time. That right there is exactly how you write a flawless, top-tier Cambridge answer.
Finally, we reach Section 4, Mastering Critical Analysis. To truly master the OR gate at an advanced A-level standard, you must be able to evaluate alternatives, compare different approaches, and provide firmly justified recommendations. Look, the examiners aren't just looking for you to trace a simple logic circuit anymore. That's basic stuff. At the syllabus 9618 standard, you might be asked to evaluate a circuit made entirely of NAND gates versus a more traditional circuit using standard AND, OR, and NOT gates.
You have to become an expert at decoding the command words. When they say evaluate, it means you are looking deeply at both the strengths and the weaknesses. Compare means you are looking at the similarities alongside the differences. And justify means you are making a final, definitive recommendation backed up by concrete, undeniable evidence from the data provided.
When an exam question asks you to compare, it is absolutely vital that you explicitly identify both similarities and differences using comparative connectives, backing each point with evidence. And this brilliantly illustrates where so many incredibly smart students drop careless marks. Here's what they do. They list all the features of Circuit A in one paragraph. Then they list all the features of Circuit B in the next paragraph. And then they just stop. Listen to me. That is not a comparison. That's just two lists. To get the marks, you must use clear comparative connectives, like whereas, on the other hand, or similarly. For example, you should write something like, both circuits will yield a positive output if either initial condition is met. However, Circuit A requires far fewer physical logic gates, thereby significantly reducing processing latency compared to Circuit B. Do you see the difference? That is a true high-level comparison. As we reach the endgame, you must evaluate algorithm quality by meticulously checking time and space complexity alongside exactly how those tricky edge cases impact overall system performance. Think deeply about how your physical logic gates translate directly into a software algorithm. If you are coding this logic, an OR statement within an IF condition evaluates extremely quickly. But what if you have heavily nested logic? You must step back and evaluate the actual processing time it takes and the memory space required. Remember those edge cases we talked about earlier. If an unexpected binary input crashes the algorithm, your performance effect isn't just bad, it's totally catastrophic.
So, you need to think 5 moves ahead. Let's recap the complete computer science answering system, the 3 rules that guarantee top marks. Number 1, command word decoding. Number 2, the Peel framework application. And number 3, the time management matrix. You have the blueprint, you know exactly where the traps are hidden, and you understand how to elevate your answers from basic facts to grandmaster level critical analysis. So ask yourself, the next time you see a seemingly simple logic gate on your exam, will you just regurgitate a truth table like Alex, or will you evaluate its space and time complexity within the wider system to claim those top marks? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.